National Electrical Code Section 334.15e addresses the installation of non-metallic sheath cables, often called NM cables or Romex, in crawl spaces and states that NM cables shall be permitted to be installed in crawl spaces with the following additional requirements: protection from physical damage. The NM cable shall be protected from physical damage by covering with a running board at least as wide as the cable or by other approved means. The code typically prohibits non-metallic sheath cables from being installed on the bottom of floor joists in crawl spaces because of the potential for physical damage. This damage could occur from contact with debris, equipment, or rodents. Installing the cables on the bottom of the floor joists would also make them more difficult to access for future maintenance or repairs. To avoid running cables on the bottom of floor joists, consider these alternatives. Firstly, install running boards along the bottom of the joists to protect the cables from physical damage. Secondly, install non-metallic sheath cables in conduit to protect them from physical damage. Or thirdly, any other method that provides equivalent protection from physical damage, such as using cable trays or protective covers. An inspector's reasoning for failing an installation like this is most likely based on the National Electrical Code Section 334.15e requirement to protect non-metallic sheath cables from physical damage. By installing the cables on the bottom of the floor joists, they were not adequately protected. To comply with the National Electrical Code, non-metallic sheath cables should not be installed on the bottom of floor joists in crawl spaces unless they are appropriately protected from physical damage. Alternative methods, such as using running boards or conduit, should be considered to ensure the safety and longevity of the installation. Let's delve deeper into the specifics of this code requirement and explore some practical solutions. The primary concern with running non-metallic sheath cables along the bottom of floor joists in a crawl space is, as the inspector noted, the risk of physical damage. Crawl spaces, by their nature, are often damp, dirty, and susceptible to various hazards. These hazards can include moisture, which can degrade the cable's insulation, physical impacts from objects stored or dragged through the space, and the presence of rodents or other pests that might chew on the wiring. All of these factors can compromise the integrity of the electrical system and create a potential fire or shock hazard. National Electrical Code Section 334.15e is quite clear that non-metallic sheath cables must be protected from these potential dangers. The code offers a few specific methods for achieving this protection, but it also allows for other approved means, giving installers some flexibility in how they address the issue. Let's examine the most common solutions. Firstly, running boards are a straightforward and effective way to shield the cables. A running board is simply a piece of wood, typically a 1x4 or 1x6, that is attached to the underside of the floor joists. The non-metallic sheath cables are then secured to the running board, keeping them elevated and away from the direct path of potential hazards. To be compliant, the running board must be at least as wide as the cable itself, ensuring that it provides adequate coverage. For example, if you are running a non-metallic sheath cable that is half an inch wide, the running board should be at least half an inch wide as well. When installing running boards, it is important to use appropriate fasteners, such as screws or nails, to securely attach them to the floor joists. The fasteners should be long enough to penetrate the joist deeply enough to provide a solid hold, but not so long that they protrude through the top of the joists. Secondly, conduit offers an even greater level of protection for non-metallic sheath cables in crawl spaces. Conduit is a rigid or flexible tube made of metal or plastic that completely encloses the wiring, shielding it from physical damage, moisture, and other environmental factors. There are several types of conduit that are commonly used in residential wiring, including electrical metallic tubing, also known as EMT, rigid metal conduit, also known as RMC, and flexible metal conduit, also known as FMC. Each type of conduit has its own advantages and disadvantages in terms of cost, ease of installation, and level of protection. When using conduit to protect non-metallic sheath cables in a crawl space, it is important to select a type of conduit that is suitable for the environment. For example, if the crawl space is particularly damp or corrosive, you may want to use a type of conduit that is specifically designed for wet locations. It is also important to properly support the conduit to prevent it from sagging or becoming damaged over time. This can be accomplished by using conduit straps or clamps that are attached to the floor joists. Thirdly, other approved means of protecting non-metallic sheathed cables in crawl spaces may include the use of cable trays or protective covers. Cable trays are open support structures that are typically made of metal or plastic. They are designed to hold and support multiple cables, keeping them organized and protected. Protective covers are typically made of plastic or metal and are designed to be installed over the cables to shield them from physical damage. When using cable trays or protective covers, it is important to ensure that they are properly sized and installed to provide adequate protection for the cables. They should also be securely attached to the floor joist to prevent them from becoming dislodged. In addition to the specific methods outlined in the National Electrical Code, there are a few other best practices that can help to ensure the safety and longevity of electrical wiring in crawl spaces. One important consideration is proper grounding. All electrical circuits in a crawl space should be properly grounded to protect against electrical shock. This typically involves connecting the grounding wire in the non-metallic sheath cable to a grounding electrode, such as a ground rod or a metal water pipe. Another important consideration is proper ventilation. Crawl spaces should be properly ventilated to prevent the buildup of moisture and humidity, which can damage electrical wiring and other building materials. This can be accomplished by installing vents in the foundation walls or by using a dehumidifier. Finally, it is important to regularly inspect the electrical wiring in a crawl space for any signs of damage or deterioration. This can help to identify potential problems early on before they become more serious. Look for signs of moisture damage, rodent damage, or loose connections. If you notice any problems, it is important to have them repaired by a qualified electrician as soon as possible. Now, let's consider some additional aspects of the National Electrical Code that are relevant to wiring in crawl spaces. While Section 334.15e specifically addresses non-metallic sheath cables, other sections of the code may also apply depending on the specific wiring methods used and the characteristics of the crawl space. For instance, if you are using a different type of cable, such as armored cable or metal-clad cable, you will need to refer to the sections of the code that are specific to those wiring methods. These sections will outline the requirements for installation, support, and protection from physical damage. Similarly, if the crawl space is considered a wet or damp location, you will need to use wiring methods and equipment that are specifically listed for use in those types of environments. This may include using waterproof or water-resistant cables, conduits, and boxes. The National Electrical Code also contains requirements for the ampacity of conductors, which is the maximum amount of current that a conductor can safely carry. When wiring a crawl space, it is important to ensure that the conductors are properly sized to handle the expected load. This will help to prevent overheating and potential fire hazards. The ampacity of a conductor is determined by its size, material, and insulation type, as well as the ambient temperature and other factors. The National Electrical Code provides tables and formulas for calculating the ampacity of conductors under various conditions. In addition to the technical requirements of the National Electrical Code, there are also some practical considerations to keep in mind when wiring a crawl space. One important consideration is accessibility. Crawl spaces are often cramped and difficult to access, so it is important to plan the wiring layout carefully to ensure that it is easy to work on and maintain. This may involve using flexible conduits or cables that can be easily routed around obstacles. It is also important to label all of the circuits and cables in the crawl space so that they can be easily identified in the future. This can be done by using wire markers or cable tags. Another practical consideration is pest control. Crawl spaces are often home to rodents, insects, and other pests that can damage electrical wiring. To prevent pest damage, it is important to seal any openings in the foundation walls or floors and to use rodent-resistant or insect-resistant wiring methods and equipment. You may also want to consider installing pest control devices in the crawl space, such as traps or bait stations. Now, let's consider some specific scenarios that you might encounter when wiring a crawl space. Scenario 1: you need to run a new circuit to an outlet in the crawl space. In this case, you would need to run a non-metallic sheath cable from the electrical panel to the outlet box in the crawl space. You would also need to install a grounding electrode, such as a ground rod, and connect it to the grounding wire in the cable. Scenario 2, you need to replace an existing section of damaged wiring in the crawl space. In this case, you would need to carefully disconnect the damaged wiring and replace it with new wiring of the same type and size. You would also need to ensure that the new wiring is properly supported and protected from physical damage. Scenario 3, you need to install a new light fixture in the crawl space. In this case, you would need to run a non-metallic sheath cable from a switch or junction box to the light fixture. You would also need to install a grounding wire and connect it to the light fixture. No matter what type of wiring project you are undertaking in a crawl space, it is important to take the necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit that you are working on before you begin any work. Use insulated tools and wear rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. In conclusion, wiring a crawl space can be a challenging task, but it is important to follow the National Electrical Code and to take the necessary precautions to ensure the safety and longevity of the electrical system. By understanding the code requirements, using appropriate wiring methods and equipment, and following best practices, you can create a safe and reliable electrical system in your crawl space. Remember that the National Electrical Code is a comprehensive set of rules and regulations, and it is important to consult the latest edition of the code for the most up-to-date information. If you have any questions about the code or about wiring in general, it is always best to consult with a qualified electrician. Wiring is a job best left to the professionals. It is important to note that local codes and regulations may vary from the National Electrical Code, so it is always a good idea to check with your local building department to ensure that you are in compliance with all applicable requirements. Failure to comply with electrical codes can result in fines, delays, and even safety hazards. By taking the time to learn about the code and to follow best practices, you can help to ensure the safety and reliability of your electrical system and to protect yourself and your family from electrical hazards. Keep in mind that electrical work can be dangerous if it is not done properly, so it is always best to err on the side of caution and to hire a qualified electrician if you are not comfortable doing the work yourself. A qualified electrician will have the knowledge, skills, and experience to safely and effectively complete any electrical project, from simple repairs to complex installations. They will also be familiar with the National Electrical Code and local codes and regulations and will be able to ensure that your electrical system is in compliance with all applicable requirements. By hiring a qualified electrician, you can have peace of mind knowing that your electrical work is being done safely and correctly. Therefore, do not risk yourself and have a professional do it for you.